Okay, hello again, dear students. We're going to start section 1-2, continuing with where we left off. All right, so we're not going to cover all the sections in this chapter 1. And I'm just going to pick and choose certain problems that I think it's good to be exposed to. So in section 1-2 on page 93, I'm going to start with number 10, which is graphing of inequalities that looks like this. And now you remember that the inequality signs, less than, greater than, less than or equal, greater or equal. Okay, so if I want to graph this on a number line, it's very simple. This is 0, this is -2, and it says x, and we always read from left to right. So x is greater than -2. So -2 is not part of the solution. Anything greater than -2. And when we say greater than -2, that means all the numbers to the right. So -1 is greater than -2, 0 is greater than -2, all the way to positive infinity. So the way we show it is that we put a parentheses, a half a parentheses like that, and we highlight all the way to the right. Now, if this was x greater or equal to -2, then instead of a parentheses, I would put a bracket. So when you see this, and you want to graph it on a number line, you use a bracket. So there you go. And then we jump to number 24. 24 is solving an inequality statement like this. So the approach is just like an equation, very simple. So we distribute, we simplify both sides first. We do that by distribution. And combine like terms if there is any. There's nothing to combine on the right side, but I can combine on the left side. So -10 and -3, that gives me -13. I'm going to go a little faster. I hope everybody can follow. And the good thing about the video is you can rewind it, and if I go too fast on a certain step. I'm going to move all the x's to the left side. You don't have to, but people are more used to that. Since I moved all the variables to the left, I'm going to move all the constants to the right. So I did it all in one shot. So these guys cancel out, so I get -8x less than 24. Now, since -8 is being multiplied by x, I need to do the opposite operation, which is dividing by -8. Now, here's the difference between equations and inequalities. Anytime you multiply or divide by a negative number, you switch the inequality sign, or you flip it over. So these guys cancel out. Since I'm dividing by -8, this is going to be x greater than, -3, because positive divided by negative. So there's your answer for number 24. And then graph the solution and write it in interval notation. So graphing it, obviously, it's very simple. If this is -3, again, this is just greater than, so you put a parentheses and you highlight. Now, what does it mean by interval notation? Interval notation is as follows. X is greater than -3, so all numbers to the right of -3. But -3 is not part of the solution because it doesn't have that equality sign under it. So I'm going to put -3 with the parentheses, comma, I'm going to go all the way to positive infinity. So voila. And I can never reach infinity. That's why I put a parentheses. If this was a specific number and it was part of the solution, then I would put a bracket around it. But that's called interval notation. I'm going to do one more that involves that. All right, so let's jump to problem number 46. Problem number 46 is two separate inequalities. And this one, I'm going to change the equation a little bit. I'm going to make this greater or equal to -1. The original problem was less than or equal to -1. This is number 46. Well, not exactly, but I just changed this. Okay, so we want to solve for x. So negative 3x minus 6 greater than 15. Negative 3x, you add 6 to both sides, gives you 21. You divide by negative 3 because negative 3 is being multiplied by x. So x is, now we're dividing by negative, so we flip the inequality sign. So x is less than negative 7. Now here, on this one, I'm going to add 3 to both sides. So x would be greater or equal to 2. Obviously, there's a word or in the middle. So how do I show it? How do I graph it? 1, 2, 1, 2, 3, 4, 5, 6, 7. There's negative 7. So x is less than negative 7. Negative 7 is not part of the solution. I put a parentheses and highlight to the left. X is greater or equal to 2. Put a bracket because 2 is part of the solution. And there you go. Again, this is not exactly like number 46, but I just modified this. Now, how do I write an interval notation? Since you have two separate inequalities, you got to write it twice. So x is less than negative 7, all the way to negative infinity. So I'm going to put negative 7, parentheses, because negative 7 is not part of it, solution, and negative infinity. And I'm going to put a parenthesis again because I will never reach infinity. Or x is greater or equal to 2. So starting at 2, but 2 is part of the solution, bracket, and going all the way to positive infinity. And again, parentheses are on positive infinity because I will never reach infinity. So there's interval notation for you. Okay, and let's jump to number 77 on page 94. If you guys have access to your textbooks online or physically, I would recommend you look at the number 77 on page 94. It's a word problem, so I'm going to read it. Jacques is going to college on an academic scholarship that requires him to maintain at least a 75% average. So 75% average minimum. Otherwise, he will be out of the program on all of his classes. So far, he has scored 82%, 76%, 65%, 71% on first 4 exams. What scores are possible on his last exam that he will enable him to keep his scholarship? So what should he get on his last exam in order to maintain the scholarship? So I don't know what he's going to get on the last exam, so I'm going to put an X. Now, 75% is the average, is the minimum. So how do we calculate averages, or mean as we call it? Well, you add up all the data points and divide by the number of data points, right? So you add all these guys up, and I'm not putting percentages because they're all in percentages. And how many do we have? 1, 2, 3, 4, 5. Divide by 5. And this average or this mean has to be greater or equal to 75%. Otherwise, he's going to get. So minimum he can get is 75, and then or larger, hopefully, or greater. Now, if it says maximum of 75, otherwise, on the other hand, the inequality sign would be other way around. It would be flipped. Okay. So, anyways, this is the setup. We want to solve for x. So how do we solve for x? We multiply both sides by 5 to get rid of your fraction, so the 5's cancel out. And then take out my calculators. 75 times 5. I'm sorry, 75 times 5 is 375. And then I'm going to add all these numbers. So 82 plus 76 plus 65 plus 71. So I'm going to get 294 plus x. So I just solve. So I subtract 294 from both sides. So x turns out to be 81%. So Jacques has to get a minimum of 81%, hopefully more, but minimum of 81% on his next test in order to stay in the program and keep his scholarship. Okay? All right, so that was a little bit of inequalities. Let's move to absolute values, which is section 1-3. I'm just going to do one problem on page 101. But before we get to the problem, let's talk about what absolute values mean. Absolute value, which we symbolize by these two straight lines, is the distance of a number from 0 on a number line. So for example, if I have 3, what's the distance of 3 to 0? We'll count the spaces. How many distances are spaces? 1, 2, 3. So if I say what's absolute value of 3, it would be 3. It's 3 spaces away. What's the absolute value of negative 3? Again, well, how many spaces is it away from 0? 1, 2, 3. So absolute value of negative 3 is also 3 because you are counting, you're measuring distance, you're counting how many spaces, so it's always positive. That's why absolute value is always positive. Okay, so let's say if I give you absolute value of x equals to 4. What is x? Well, can x be 4? Of course, because what's absolute value of 4? 4. Can x also be negative 4? Yes, because what's absolute value of negative 4? 4. So x can be both of these. It's either 4 or negative 4. Okay, keep that in mind as we solve number 10 on page 101, because we have an equation, negative absolute value of 3q. Now my students in previous years always makes fun of my lowercase q. I don't know why. I think it's pretty cute to me. Ha ha ha. Bad jokes. Okay. So anyways, so how do I solve this equation for q? So the first thing is you want to isolate the absolute value. So cancels. So you get negative 3q plus 4 equals negative 8. Now here's a negative 1 here, right? A negative 1 is being multiplied. So I'm going to, what's opposite of multiplication? Division. I'm going to divide by negative 1.